Now look at the next part, part 3 of electrolytic cell. Next question is fifth one. Weight of silver, right? So silver is Hg. Weight of silver displaced by quantity of electricity which displays 5600 ml of O2 at STP. Right? Atomic weight of silver is given. That is 108. You have to find the mass of the silver deposited. Right? Asked in AIPMT 2014. So see here, I will explain it. So 1 mole of O2 contain at STP. This is the standard value at STP. 1 mole of O2 contain 22,400. So it will be 22,400 ml. So here given is how much? 55,600. So please calculate this one. So how many moles? So X mole, suppose X mole of O2. So it will be how much? 55,600 divided by 22,400. So calculate this one. Mole of O2. Unitary method. We were using here a unitary method. 1 mole contain 22,400. So X mole contain how much? So this 2 and these 2 will get cancelled. And solve it. So it will be divided by 1/4. So it will be 1/4 mole of O2. Right. So this much of mole. And yesterday I have told you the formula for mole. Mole is nothing but mass upon molar mass. So mass is nothing but it is mole into molar mass. So mass is equal to, mole is 1/4. Molar mass of oxygen is atomic mass of one atom is 16. Atomic number is 18. So for O2 it will be 2 into 16, that is 32. So what will be the answer here? It will be 32. So please solve it. It will be 8. So 8 gram of oxygen is deposited. Now see the next part. Now according to equivalent, right? Or according to Faraday's second law. Faraday's second law. Equivalent of silver is equal to equivalent of O2. Equivalent of O2. So it will be weight of silver. Weight of silver. Right. By equivalent weight of silver. Equivalent weight of Hg is equal to weight of O2 divided by equivalent weight of O2. Weight of O2. So write here weight of Hg divided by equivalent weight is molecular weight upon factor 1. So because silver dissociate into Ag plus and 1 electron will be coming out. So factor here is 1. Similarly for O2, right here weight of O2 divided by molecular weight of O2 divided by 4, because factor is 4 now. So now cross multiply or put the value first. So for oxygen weight is 8, we have got, divided by molecular weight is 32, divided by 4 is equal to weight of silver into molecular weight of silver is 108 divided by 1. So calculate it, you will get the answer. This is 8, this will be cancelled by 8. So equivalent weight of silver will be 108 gram. So write down. Now see how we have written here factor 4 for oxygen. I will explain you. See here. So when water dissociate H2O, right? So we have to form oxygen, right? So I will take here 2 moles of water. Then it will become O2, right? Because here then atom will be 2, right? That's why it will form O2. For producing 1 mole of oxygen, we have to take 2 moles of water. And hydrogen coming out will be 4H plus. And electron will be 4E minus. So you can see here, balancing factor is 4. That's why we have used there 4, right? Here, for oxygen. So oxygen required electron is 4 moles. That's why, right? Now look at the next sum, sixth one. Asked in 2009. Aluminum oxide Al2O3 is reduced by electrolysis at low potential. Is reduced by electrolysis at low potential and high current. If 4.0 into 10 raised to 4 ampere of current is passed. So current value is given, that is 4 into 10 raised to 4 ampere of current is passed through the molten aluminum oxide Al2O3 for 6 hours. So convert into second. So 6 into 60, then it will be in minute, is equal to 60 into 60 into 60. So it will be 36, 0 into 60. So how much it will be? 6, 36, 3, 18, 21 second. 21,000 second time will be. So what mass of aluminum? We have to find the mass of aluminum is produced. And atomic mass for aluminum is, atomic number is 13, atomic mass is 27. This one you have to find. Now see, I will write the first reaction stepwise. So first is the reaction of ionization. So it will be Al2O3 dissociate into Al3 plus and AlO3 minus. Right. So this is plus, so it will deposited at cathode. This is minus, deposited at anode. Right. So the reaction at cathode will be. So at cathode reaction is Al3 plus 3 electrons. So cathode at reduction will be, reaction will be reduction. Gain of electron is called reduction. So it will form aluminum solid. So it required 3F. 3F means 3 Faraday. Then it will produce 20 gram of aluminum because atomic mass of aluminum is 27. So it is the ratio of 3:27. Next is, now mass of aluminum deposited of 3 Faraday is 27 gram. So mass formula is, so mass of aluminum deposited is equal to 27 molecular mass into current. This is your molecular mass. This is your current. 4 into 10 raised to 4. And time we have converted, that is, right, we have converted 21,600, right? You can see on the back side. Divided by factor. So factor is 3F. Now solve it, you will get the answer 8.1 into 10 raised to 4 gram of aluminum deposited. So this much amount of aluminum is deposited. So write this one. Now look at the seventh question. 4.5 gram of aluminum atomic mass is given, that is 27U, is deposited at cathode. Deposited at cathode from Al3 plus. Solution by certain quantity of electricity charge. The volume of hydrogen produced at STP, right, from H plus ion in solution by the same quantity of electricity passed. So you have to find the H plus quantity here. Asked in 2005. So see here, we will use Faraday's second law. So mass of aluminum divided by mass of hydrogen is equal to equivalent weight of aluminum divided by equivalent weight of hydrogen. So this is called Faraday's second law. Faraday second law. So aluminum value gram mass is given, that is 4.5. Now put the value. So it is 4.5 gram divided by, you have to find the mass of the hydrogen is equal to equivalent weight of aluminum is, it is 27, factor is 3 because here 3 electron is losing, divided by 3. And equivalent for hydrogen will be 1 upon 1. Now calculate it. So this will be 9. So mass of hydrogen will be 4.5 gram divided by 9. Remove this 10, so it will get here 10. Now 9 5s are 45. So it will be 0.5 gram of hydrogen gas deposited. Right. If you want to convert into volume form, then as we know, volume of 2 gram of hydrogen at STP contain 22.4 liter, right? 1 mole contain 22.4 liters. So converted into gram. So 2 into 1, right? Because 2 atom is there. That's why we have written here 2 gram, 2 into 1. Then for 0.5 gram, what will be the volume? So volume of 0.5 gram of hydrogen at STP is equal to 22.4 into 0.5 divided by 2. So answer will be 5.6 liter. Understood? So we have used unitary method. So 22.4 divided by 2 for 1 gram. And for 0.5 gram, it will be multiplied with that one, right? So this will be the answer in liter and this will be the answer in gram of hydrogen. Now look at the eighth one. In electrolysis of NaCl, when platinum electrode is taken, so for sodium chloride, platinum electrode is there. And then hydrogen gas is liberated. Here hydrogen gas is liberated. at cathode. At cathode. While with mercury cathode, it forms sodium amalgam. And for Hg is also called as amalgam. So here sodium amalgam is used, NaHg. So name is sodium amalgam. Right. So find it. So see, first we'll write the reaction for NaCl. So it will be converted into Na plus Cl minus. And for water it will be H plus OH minus. Right. When electric current is passed through the solution using platinum electrode, so Na plus and H plus move towards cathode. Right. So this reaction is happening in a container. So this plus part will be moving towards cathode because cathode is holding minus charge. In the similar manner, this minus part will be attracted towards anode because of the positive charge. Right. So at cathode it will be H plus E minus. It forms H plus atom after gaining the electron. So reduction happens at cathode. So when we are taking two atoms of hydrogen, it forms H2. In the similar manner, for at anode, oxidation will be happening. Oxidation means loss of electron. Loss of electrons. So it will be Cl minus will be converted into Cl plus 1 electron will be coming out. So by combining these two atoms of chlorine, you will form Cl2 gas. Right. If mercury is used at cathode, H plus ions are not discharged at mercury cathode because mercury has a high hydrogen over voltage, high hydrogen. Thus, H plus ion are discharged at cathode in the presence of H plus ion yielding sodium, which dissolve in mercury to form sodium amalgam. Right. So this part, if you want to write, then write. Write up to this point only. So option will be P. So more voltage is required to reduce H plus H cathode. If you are using mercury, so high voltage is required. High voltage is required than platinum. So B option is correct. Now look at the ninth sum. A current is passed through a solution of zinc sulfate. I current 5 ampere is passed through a solution of zinc sulfate. Zinc sulfate for 40 minutes. The amount of zinc deposited at cathode will be the amount of zinc you have to find. So see here, current time value is given. So convert into seconds. So it will be 40 into 60. Now we know the value Q equal to IT. This is the first formula. Q is charge, I is current. So it is 5 into 40 into 60. It will be how much? 5 into 4 is 200 into 60. So it will be 12,000 coulomb. Right. Second formula is reduction of zinc. So it will be Zn2 plus gaining 2 electron forming Zn. Right. Next is equivalent weight of formula. So Faraday first law. So weight equal to ZIT. Right. It is nothing but mass upon NF. N is factor and F is Faraday value. Z is equivalent mass. equivalent mass. Molar mass of zinc is equal to 65.39. So put the value here, then it will be 65.39 divided by 2 into 96,500 gram of zinc. Now see the next step. So 12,000 coulomb of charge will be deposited. Equal to 65.39 equivalent into charge by factor. Factor is 2 and Faraday constant is 96,500. So mass deposited is 4.065 into gram of zinc, right? So here we use here formula. This is 65.39 is molar mass and this is your Q charge divided by factor NF into Faraday constant. So this is the value here put. So this value after putting you will get the mass of an element. Mass of an element. Now see the next topic based on electrochemistry. So next will be based on electrochemical cell. Electrochemical cells and for galvanic cell and based on Nernst equation. Nernst equation. So first question asked in 2020. So in a typical fuel cell, reactant and products are. So it is directly based on hydrogen fuel cell. So I will explain, fuel cell is nothing but it is the combination of hydrogen and oxygen to form the water, right? So option will be B. So reactant is hydrogen and oxygen. So this is your reactant part and this is your product part. So in fuel cell we use hydrogen and oxygen as a reactant and form product, right? So this is the answer of first one. Now look at the second one. For a cell involving one electron, E naught of cell is equal to 0.59 volt at 298 Kelvin temperature. The equilibrium constant, so you have to find K, that is equilibrium constant for the cell is, so you have to find K value and other value of given, that is 2.303 RT upon F value, that is given 0.059 volt. This question is asked in 2019. So equilibrium constant value you have to find it. So see the explanation. We will using here Nernst equation. So I will write the first step. E of cell is equal to E naught of cell, that is given, E naught of cell is given 0.59 minus 2.303 RT upon NF. NF comes, right? And this value has calculated for you into log of equilibrium constant. So it will be Q here. Q is reaction quotient. Reaction constant, right? So this is the standard equation of Nernst equation. So this whole form that is written is Nernst equation. Nernst equation. So see, for equilibrium, yeah, or at equilibrium, E naught of cell is equal to 0. Q equal to K equilibrium. So this is equal to equilibrium constant. Equilibrium constant. This is your reaction constant. Reaction constant. Right. E naught of cell, E of cell will be a standard cell potential is not 0. So E of cell. Right. So put in the formula this value in the first. So it will be 0 equal to E naught of cell minus 0.059 upon N log of K equilibrium. E naught of cell is equal to 0.059 upon N log of K equilibrium. So factor for 1 electron, N value is given, that is 1 electron. So put here N equal to 1. E naught of cell is given, that is how much? 0.59 divided by 0.059 is equal to log of K equilibrium. So this will be cancelled. So here 10 will be remaining. So log of K equilibrium is equal to 10. So K equilibrium will be 10 raised to 10. So this is the value for K equilibrium.